Welcome back to the deep dive. You know, one of the biggest challenges with machine intelligence right now is just trusting the answer you get.
Mm-hmm.
That little voice in your head that wonders, is this AI just confidently making stuff up?
Right. The hallucination problem.
Exactly. And today, we are tearing into a piece of research that claims to have, well, a solution to that very problem.
We are going deep on the architecture of something called the Recursive Deep Knowledge Engine, or RDKE.
And specifically, V2.0, the Physarum edition.
Yeah, and our mission here for you is to really get under the hood and understand not just how this thing works, but how it's trying to shift AI from just, fetching info to providing instant, verified, deep research.
Research that is structurally incapable of hallucinating. That's the big claim.
That's the claim.
And the most wild part of this to me is that this super advanced AI is taking its cues from a brainless single-celled organism.
A slime mold.
It's an incredible angle. We're talking about a system that has a kind of built-in curiosity.
And that's the key shift. I mean, the core vision here from the concept author Kodrat Marius Gerassim, it just moves the goalpost completely. We're going from what you could call reactive AI.
The stuff we use every day. You type in a prompt, it gives you an answer.
Exactly. It just sits there and waits.
Yeah.
This moves us to proactive intelligence, a machine that basically works by asking questions first. It's constantly auditing the world and itself.
Okay, hold on. If an AI is proactive, how does it know what to even look for? Isn't it just creating a ton of noise?
Well, that's where the architecture is so clever. RDKE doesn't just store data like a big hard drive. It compresses global knowledge into these really dense meaning and truth graphs.
Okay.
And the whole system gets its adaptive reasoning by treating one specific thing as its fuel.
Which is?
Uncertainty as nutrient.
Uncertainty as nutrient. What does that mean?
It means if the system finds a gap or a contradiction or maybe a connection with a really low trust score, that becomes food.
I see.
It drives the engine to go explore, to verify, to fix it. So you're creating a knowledge structure that is designed to heal itself, to grow.
That makes it sound less like a computer program and more like a living thing, constantly trying to find balance.
That's the analogy.
Okay, so before we get too lost in the slime mold biology, let's ground this a bit. What did RDKE v1.0 actually establish? What was the foundation?
Right. V1.0 was absolutely essential. It was the proof of concept, really. It showed that this model of continuous knowledge compression was even possible. The whole system had to support this recursive deepening of understanding.
Meaning it doesn't just learn new things, it uses the new stuff to refine its understanding of the old stuff.
Precisely. It's not a one-and-done training run. It's like a constant internal audit.
Okay.
And to get to that promise of millisecond answers, V1.0 had 4 sort of critical components.
Let's break them down. What's the first one?
First, you have the semantic knowledge atoms. These are the nodes in the graph, but they are incredibly specific. They encode whole complex concepts and relationships, not just, single words.
So they're not just rows in a spreadsheet. They're like bundles of ideas all linked together.
That's a good way to put it. Second is the truth graph epistemic memory. This is the core structure.
Okay.
It's a graph where every single connection, every edge, is weighted not just by how related things are, but by a verified truth score, a provenance score.
So it's the roadmap, but it's also the audit trail for that map.
Yes, exactly.
That sounds like it would be a lot slower than just a standard database lookup. How do they keep it fast?
And that brings us to the third element, autonomous self-questioning and exploration cycles.
Recursive part.
The recursive part. The engine is constantly poking at its own knowledge, testing its boundaries, filling in gaps before you even ask. So when a query comes in, the common pathways are already verified, already reinforced to sort of pre-research the topic.
It's ready for you.
It's ready. And the fourth piece, that's the one that addresses the transparency problem we always see in AI.
The black box issue.
Right. V1.0 was built for transparent evidence and counter-view synthesis. You don't just get an answer. You get the verified sources that built that answer and any known, well-supported opposing viewpoints.
All synthesized for you instantly.
Instantly. So that whole architecture really laid the groundwork for deep research you could actually trust.
Okay, so the foundation is solid, but this is where it gets, for me, really fascinating. The jump to V2.0, the Physarum edition. How on earth does a simple slime mold inspire a huge leap forward in AI architecture?
Well, the slime mold, Physarum polycephalum, is an absolute genius when it comes to pathfinding.
Yeah.
It's biological optimization at its best. If you put down food sources, like, say, oat flakes in a petri dish, the mold extends these little protoplasmic tubes and it forms this complex network to all of them. But over time, it reinforces the tubes that are the most efficient transport routes between food sources, and it lets the inefficient, unused paths just sort of wither away and die.
So it creates the perfect transport network, all without a brain or any central control.
Exactly. And RDKE v2.0 mimics that exact strategy for its knowledge network.
It's an adaptive system.
Yes, the knowledge structure now behaves like that living network. Uncertainty, as we said, is the nutrient that forces it to explore. And if a piece of knowledge is used over and over and it's verified high provenance, that connection gets stronger, the tube gets wider.
Making that path computationally easier to travel down.
Right. And if a connection isn't used, or worse, if it leads to a contradiction, the tube shrinks. That path becomes computationally harder to use.
This still feels like it would be inherently slower, though. If you're prioritizing these longer, verified, stronger paths, aren't you giving up the raw speed that you get from large language models?
And that is the critical trade-off that the sources get into. It brings us to this core idea of epistemic flow.
Epistemic flow.
Right. A standard LLM or a simple vector search, it's all about speed. Finding the shortest path, most statistically likely sequence of words. It's built to prioritize computational efficiency.
So an LLM is basically designed to take the shortest highway, even if that highway is known to have a bunch of, informational potholes.
That's a perfect analogy. RDKE with epistemic flow does the opposite. It prioritizes routing its attention, its computation, through paths that are verified by high provenance evidence.
Even if they're longer.
Even if they're longer. So if the true path takes 3 hops, but a faster unverified shortcut takes 2 hops, RDKE is engineered to favor the 3-hop path. It's designed to choose veracity over efficiency.
That's a fundamental change in philosophy.
It is.
And this focus on verifiable truth, that leads us right to the solution for what they call the hallucination trap. How do these graph dynamics, these Physarum dynamics, actually stop the system from taking that tempting, short but false route?
So when a query comes in, the node representing your unknown answer acts like a new food source, a nutrient source. The computation starts moving through the graph towards the established known facts.
And normally that flow would just find the path of least resistance?
And that's often a hallucination because it's statistically plausible and computationally cheap.
But V2.0 throws up a huge roadblock, a kind of computational hurdle.
A hurdle is a good word for it. It's the core innovation. Truth friction. It's resistance, imposed directly on any pathway that lacks verifiable evidence. And it's baked right into the math, the modified Physarum update rule that decides if a pathway grows or shrinks.
Okay, let's unpack that update rule because the sources are really specific about it. The change in a connection's weight is all about the relationship between 2 things, flux and provenance.
Right. Before we get to the formula, let's just think about those 2 ideas. In any system that's looking for an answer, you have 2 forces pulling at it.
Yeah.
The first is flux. Flux is just the system's drive to get the answer. The amount of computational attention flowing down a path, it's a measure of efficiency.
It's the engine wanting to hit the gas pedal.
Exactly. The second force is provenance, and that's the verifiable truth score of the information on that path. It's an objective measure of veracity.
So you have speed versus truth.
Speed versus truth. And the formula forces them to multiply. The reinforcement of a path is based on flux times provenance minus, a small natural decay factor.
So by multiplying them, what does that do?
It creates the friction. If the flux is high, the system really wants to use a path, but the provenance is really low, say 0.1, then that multiplication gives you a tiny, tiny reinforcement value. The path doesn't get stronger. In fact, compared to other paths, it gets weaker. The computational cost of using that unreliable shortcut effectively goes way up.
So low provenance paths create their own resistance. The system is literally designed to make lying or guessing the harder option. It's just easier to take the audited route.
That's the whole innovation. The system avoids the hallucination because the false path, even though it's shorter on paper, it just costs more energy to use because of that friction. It's an economic penalty for being untruthful.
This is great in theory, but, the proof is in the pudding. They designed this brilliant little test to confirm it works. They call it the synthetic adversarial benchmark.
Or the hallucination trap.
The hallucination trap. So what was the setup for that?
It was a direct competition, basically designed to trick any AI that's just optimizing for speed. They set up 2 pathways to the correct answer.
Path A was the truth. It was longer, 3 hops, so it was slower, but it had a really high provenance score of 0.9.
And then there was path B, the tempting hallucination.
Yeah.
Much faster, only 2 hops long, computationally cheaper. But, and this is the key, it had a low provenance score of 0.4.
So the choice was simple. Speed or truth?
Speed or truth?
If RDKE behaved like a normal LLM, it should have picked path B every single time. It's the path of least resistance.
It should have.
So what did this study show when they ran the full RDKE variant?
With the full system, with the provenance-weighted dynamics turned on, it achieved 100% accuracy.
100%.
Every single time. It felt that truth friction on the shorter path, and it correctly chose the longer verifiable path A.
Wow. And what happened when they turned the friction off, the no provenance variant?
The results were pretty stark. The second they told the system to ignore the truth scores, it just reverted to pure speed optimization. It chose the hallucination path B every single time. Accuracy dropped to 0%. Zero. And that's the confirmation. This bio-inspired provenance-weighted system isn't just a nice feature. It is the essential mechanism that prevents these structural hallucinations.
So that confirms it. A system built on this idea of epistemic truth can absolutely override the seductive logic of just statistical chance and computational shortcuts.
Yeah.
This feels like a complete shift in how we build trust into AI.
It really is. The vision is clear. We're building knowledge that's instant, yes, but also fundamentally demonstrably true. It's an engine that's engineered to value the cost of verification more than the cost of computation.
And the sources are already pointing toward prototypes and how this gets applied in the real world.
Oh, absolutely. They talk about future work on defining better metrics to evaluate this kind of adaptive intelligence and, crucially, developing self-regulating safety systems.
Which you'd need. If a system is proactively exploring knowledge on its own, it needs some very strong guardrails.
You need strong rules of self-governance, for sure.
And this whole deep dive, it feels so relevant for anyone just trying to navigate the information world we live in today. If we can actually use systems like this that give you transparent evidence and counterviews, it becomes this firewall against information overload and even against intentional misinformation. The burden of verification shifts from you to the machine.
And it doesn't just give you the insight. It gives you the full audit trail of how it got there, with confidence levels attached to every single piece of evidence. You get the knowledge and you get the confidence score.
So we've gone on the whole journey.
Yeah.
From the V1.0 foundation of knowledge compression through this adaptive living network inspired by a slime mold.
And finally, to that revolutionary mechanism of truth friction that forces an AI to value provenance over just raw speed.
RDKE V2.0 really does seem to be a blueprint for machines that are built from the ground up to seek out and value verifiable truth.
It makes it computationally extensive to be wrong.
Which leaves us with a provocative final thought for you to think about this week. If our most advanced machine intelligence is now being explicitly designed to value verifiable truth provenance over computational efficiency, the path of least resistance, what does that suggest about our own habits? I mean, are we as humans prioritizing speed and ease over depth and complexity when we look for information? So think about that the next time you're searching for something. Are you choosing path A or are you choosing path B?
Keep diving deep and keep questioning the provenance of your own knowledge.
Until the next deep dive.